Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi everybody. So let's move to the next chapter of our topics, which is ocean gyres. So we're going to learn about ocean currents. So I understand that in the earlier parts of the semester, we have a look at basic concept of ocean current, how ocean current moves, what's the driver of ocean currents. So I think in the basic concept, we understand that ocean current move because of wind, and it's also moved because of different pressure gradient. Wind is actually influence the surface current. Pressure gradient influence the movement of bottom currents. So that's the simplified version. Of course, there's lots of other factors involving Coriolis, involving Ekmans, involving vorticity and whatnot. But let's have a look at how winds actually influence the large ocean system. And by talking about ocean gyres, we're going to look at the real situation in the global scales, how ocean current moves. So as a marine science students, I believe that it is important. It's a very important concept that you need to understand, because when you study physical oceanography, people will expect you to understand about ocean currents, and understanding the global concepts of ocean currents. That's what's important in these topics. So let's have a look at one by one. So in this lecture, we will go and try to understand how these ocean currents move warm water from low latitudes to higher latitudes, and also how the ocean currents move the cool water from the high latitudes to the lower latitudes. But the most important things in this lecture, you will need to understand how the ocean gyre form. So we have 5 big ocean gyre in the global scale. So we will try to understand how ocean gyre form by applying the concept of Ekman dynamics. And then the next part, we will try to understand, and you will need to apply those ocean gyre concept and understand western boundary currents and eastern boundary currents. So there's 2 boundary current system that will be a major ocean currents that you need to understand for you to understand the whole concept of ocean gyre. And then we have the final one, western intensification, which is the concept where you have 2 different strength of current between western and eastern boundary current. So those different are actually caused by western intensifications. Okay, this lecture will be split into 2, so you will have 2 different lectures, videos for this lecture. So we will go and try to understand the major current system, which is the subtropical gyres, eastern and western boundary currents. This is where the major ocean currents are. I'm not going to go into details in subpolar gyres and Atlantic circumpolar currents. This is as long as you can understand the basics of subtropical gyres, so that will be enough. The equatorial equatorial current system are quite straightforward. So it is actually parts of the big gyre system. So so this is the basic things that we will learn in this lecture. Alright, so there you are. So we study ocean currents as part of physical oceanography. That is physical oceanography is all about. So we study current system. So if you study and become marine science student, but you don't understand about current system in the ocean, so that's not enough. So you need to understand the ocean currents, and the first parts of understanding ocean current is by looking at the major surface current system of the world. So we have all of these big ocean gyre. So this is the 5 ocean gyre: North Pacific gyre, South Pacific gyre, North Atlantic gyre, South Atlantic gyre, and Indian Ocean. So Indian Ocean, you only have 1 gyre system, because you don't have ocean on the northern part. So this is 5 major ocean currents in the world. Alright, so if you look at here, so you will have basically all these big current system of the world. So you need to, at least as a marine science student, you need to know what the current system, the name of the current system. So for instance, is Aguas Current, Western Australian Current, Benguela Current, Canary Current, Gulf Stream, California Currents, Peru Currents. So we will learn how this current system evolved from the concept of Ekman dynamics. But first of all, you need to understand what is ocean gyre. So ocean gyre is a large system of circulation of ocean currents, particularly those involved with large wind movement. So in this case, we are referring to those big oceans of the world: Pacific Ocean, Atlantic Ocean, and Indian Ocean. And based on the topography, so we split these basins into two, which is north and south. So we have North Atlantic Ocean, South Atlantic Ocean, North Pacific, South Pacific, and Indian Oceans. So gyres are caused by Coriolis effect, right? Planetary vorticity, and of course the vertical friction of Ekman, which determined by circulation pattern from the wind stress curve. So it is, when we talk about Ekman dynamics, it's all involved wind, and it involves a movement of water transport. And let's have a look how those ocean gyre form. Alright, so this figure looks familiar. So we learned about this in the atmospheric global circulation. So we just want to take one example. So this example, so you will learn one example and apply this to other ocean basins. Alright, so this is North Atlantic Basin. So you have the northeasterly trade winds, and then you have westerly winds. Alright, so these two wind system is actually the one that responsible to create this ocean gyre. But of course, the story is very long, so we will learn how this actually forms in a through the process of Ekman dynamics. Okay, so if you look at here, so this is the wind stress. So the northern part is moving in right direction. The between 30 degrees to 45 degrees, you have wind moving to the right direction. 30 degrees to 15 degrees, it's moving the northeasterly winds. So I'm going to show you basically what actually happens in those systems and how this wind system creates those ocean gyres. I know it might look simple, so if you can think simply, you can say that, alright, so the wind is going to this direction, and then the current is going here, and then it moves to the south, and it creates one big gyre. It's not as simple as that. It is much more complicated. So let's have a look how it happens. Again, so you have horse latitude at 30 degrees north. So you have westerly wind in the north, and then you have trade winds in the south, and then you have Ekman dynamics. Alright, so you have Ekman dynamic, both area moving to the right of the wind system. So this trade winds moving to the right of the wind system, this trade wind moving to this westerly winds moving to the right of the system. So what happens in the middle? So when you have two Ekman transport moving at the same place, it will create a bulge in the oceans. So this is the bulge system that was created when you have this Ekman transport in the middle. So it creates a dome shape in the middle of the oceans. So it looks, we exaggerate this because actually in the real ocean, so this high center and the at the coastal region of those ocean basins, so actually the distance is about 8 to 9,000 kilometers, and the height between the sea level of this high and this low area is only about 1 meter high. So you can see the proportion is very, very small. But in the case of ocean dynamics, so that can actually create a very strong current moving from higher pressure area to the low pressure area. So you have this bulge. What happened is, so you have convergence, so you have a movement of water from higher place to the lower place, which is what we call as a pressure gradient force. So pressure gradient force means water move from higher pressure area to the lower pressure area. Alright, so when they move down from the higher area to lower pressure area, it was balanced by the Coriolis force. So what happened is, it moving down, but at the same time it when the balance of Coriolis force happens, so it moves to the right of the northern hemisphere. So it moves to that into the screen. So again, you get this one, pressure area having the same effects. So those actually creates this North Atlantic Ocean. There you are. So you have 5 ocean gyre. If you apply all those Ekman dynamics concept in these 5 gyre system, so you will get to understand how these actually form at those particular ocean gyres. Right. So when you have this gyre system, so you have all these major current system of the world. So take for example the Northern Pacific Ocean. So you have the California current, and then you have the North Equatorial current, South Equatorial current, Equatorial countercurrent, Kuroshio currents. So all of these current systems are actually formed as part of the ocean gyre. So you can go one by one to other current system, to apply the context of these ocean gyres and the Ekman dynamics. So let's take one example, which is North Atlantic Ocean. So if I can draw you so the boundary. So this is Europe area, and then this is the America area. Right. So what you have is northeasterly winds moving into this direction, and then westerly winds moving to that direction. Okay. So I mean, to make it so what happened is, if you have this kind of wind, so what happened in terms of Ekman dynamics? So basically Ekman dynamics is moving to the right, because both is in northern hemisphere, and this will also move to the right, move to the right, move to the right. Okay, so when you have transport moving into one direction, and then again another one moving into the same direction, so you will create accumulation of waters in the middle. So what happened is, if you look at cross section, dome shape, because water is accumulated in the middle. Okay, so when it comes to dome shape, water from the higher pressure area, or higher pressure region, will tend to move to the lower area. Okay, it's like you rolling a ball. So kalau ada bola sini, you roll, dia akan turun ke bawah. Okay, so that's what happened. So water moving from the high area to the lower area. Okay, so but when that happens, so this is that is pressure gradient. It moves because of pressure, but at the same time the world is moving, and we have the Coriolis force. So Coriolis force will balance out this movement of water. So what Coriolis do is, when it balance out, so this water, instead of moving down, it will move to the right. So it will go out. So if you look at the gyre system, so pressure gradient moving down the hill, and then the Coriolis is balance out this pressure gradient and tend to move to the right. So the whole water will move to the right. So just imagine those forcing is actually happens throughout the ocean gyre. So that's how actually ocean gyre are being created. Alright, so so you have actually starting with winds and Ekman dynamics, and Ekman dynamics push water and accumulated in the middle, create a dome, and then you have water moving down, balanced out by Coriolis, and you have those ocean gyre being formed. So that's the basic concept that you need to understand how ocean gyre is forming, and that's how the big and major ocean current system in the world is forming.